average rate of change. So I'm going to read this here. It says linear functions have a constant rate of change, also known as slope. With nonlinear functions, it's often useful to calculate the average rate of change to understand the data. The formula for the average rate of change is the same as it is for slope. So the formula is basically just rise divided by run, or your change in your y divided by your change in x. Or you can, if you want to, you can continue to use this y2 minus y1 formula, which is basically just the change in y divided by the change in x, right? Because y2 minus y1 is the change in y, and x2 minus x1 is the change in x. So let's get on with it. Number one says, whoops. In 2022, the stock price of a popular electronics company has dropped over the year. The graph shows the stock prices at the beginning of each month over said year. So A says, what is the average rate of change from February to June? So if you look at this graph here, it's not linear, right? So it's not just strictly the slope, right? It's not linear. So what we're going to create is kind of the average from February to June. So if I look at February to June, it definitely looks like it's gone down because it started up at 186.98 and then it went down to 116.42. So this average rate of change is definitely going to be negative. So think about this. It's going down. And we're going from February to June. So that's over that 4 months, February to June. You can count if you want. 1, 2, 3, 4. Over the 4 months, it's gone from 186.98 to 116.42. So let's figure out how much exactly it's decreased by. So I can do 116.42 subtract 186.98. And this is all over the 4 months. Now, if you can't, if you're not counting from February to June, you can also label June as the 6th month of the year and February is the 2nd. So I could say 6 minus 2, which is 4, right? It's over the 4 months. So how much has it decreased over the 4 months? Let's calculate that. 116.42 subtract 186.98. So it's gone down 70.56 over 4 months. Divide that, and we got negative 17.64. Now, since this is a word problem, I do kind of want to interpret that. Negative 17.64, that's the average rate of change. But what does that mean? Well, what that means is the stock price decreased on average by $17.64 per month. That's what I would say. Now, I showed all that work there. Now, if you can do this with a little bit less work, feel free. Like, for instance, I would have put 4 immediately on the denominator because from February to June, I know that's 4 months. And then, just subtract the top 2 numbers there. Let me show you B. It says, what is the average rate of change from June to September? Let me erase this stuff. Okay, June to September. So I know this is 3 months, right? June to September, 6 month. This is the 9th month of the year. And if I look at how the stock price has acted, it looks like it's gone up. So I should have an increase. So if we looked at A, we saw a decrease. On B, we should see an increase. So let's see exactly how much it went up. So it went from 116.42 to 152.47. So if I go 152.47, I subtract 116.42, that'll tell me how much it's gone up over the again, over the 3 months from June to September. And you can do 9 minus 6 if you want, which is 3. So over the 3 months, how much did it go up? Let's calculate that. So let me use my calculator. 152.47 minus 116.42. I got 36.05. So it looks like it's increased by 36.05 over 3 months, divided by 3. And I got 12 point, I'm going to round here, 02. So the stock price increased this time around, increased by $12.02. I guess on average, I'm going to add that in there, on average per month. And that's from June to September. I'll do one more. January to November. Okay, January to November. So that's a long time. The first month, which is January, all the way to November, which is the 11th month. So that's 10. So we're looking over 10 months. So keep that in mind. January to November. That's 10 months time. Whoops. So January started at 182. Then, so this is definitely a decrease. 182.23 to 125.41. So definitely a decrease. So how much did it decrease over those months? So 125.41 subtract 182.23. And this is over the 10 months, right? From January to November. Just for work's sake, I'm going to do November's the 11th month. So 11 minus January's the first month. So 11 minus 1. So over the 10 months. 125.41 minus 182.23. I got negative 56.82. Divide by 10. Negative, I'm going to round again, 68. So this is a decreased an average of $5.68 per month. All right. Hopefully that made sense. I'll let you try number 2. Okay, you try number 2. I'm going to show you number 3 now. It's the same concept except with a table. It says the quarterly data reports for a growing stationary bike fitness company are given in the table below. It shows the number of subscribers in thousands over each quarter of the years 2020 and 2021. Okay, here we go. It says, what is the average rate of change for a quarter from Q1 2020 to Q3 2022? Okay, let's do, okay, Q1 2020 to Q3 2020. Okay, so that's just 2 quarters, right? And it's kind of, so we're going from Q1 to Q3. That's just over 2 quarters. Okay, so and it went from 563 to 886. So I know this is an increase. So I'm going to go 886 minus the 563, and on the bottom, hang with me here, I'm just going to put 2 because over 2 quarters, I'm going from Q1 to Q3. Similar to, like, you know, I started on this problem earlier, labeled like this is my first month, second month, third month. You can do that kind of down here too, if you want. You could label this 1, 2, 3, 4, 5, 6, 7, 8 if you need to. But I just realized, okay, from Q1 to Q3, that's 2. Okay, so that's 2 there. So over those 2 quarters, 886 minus 563, 323 divided by 2, 161.5. So the answer, 161.5 average rate of change. So it would be increased on average by 161.5. Remember, this is in thousands. 161.5 thousand per quarter. If I had more space, I'd probably, make a longer sentence. But the idea is that the subscribers over those 2 quarters have increased by, on average, 161.5 thousand per quarter. Okay. Let me do B. Okay. Erase this first. All right. Average rate of change for a quarter from Q4 2020 to Q4 2021. Okay. So this is 1, 2, 3, 4 quarters. So this is over 4 quarters worth of time. How much did it change? So it increased again, right? So how much did it go? So it went from 1,091 to 2,331. So I could do 2,331 subtract 1,091. That's 1,240. An increase in subscribers by 1,240 over 4 quarters would be how much per quarter? It would be 310. An increase of 310,000 subscribers per quarter on average. Okay. I'll let you do 4. Now, word problems. Let's look at this. So it says Andrea invests an amount of $8,000 in a money market account at an annual interest of 3% compounded quarterly. The function f of x, 8,000 parentheses 1 plus 0.03 divided by 4 times 4 to the power of x represents the value of the investment over x years. So that formula, this formula is, I'm not going to get into where it came from, but remember to go back to our compound interest units if you need to, which was in the exponential unit. But we don't really need to know where the formula came from so much from this for this sort of problem. So it says find the average rate of change in the value of Andrea's investment between year 2 and year 6. Okay, so this is over 4 years. So from year 2 to year 6. But first, this is what makes this one unique. It doesn't tell us what the value of it was at year 2 and what the value of it was in year 6. Like for the table, it told us the subscribers here, and it told us in the graph, it told us how much money stock prices were and gas prices were. Like it told us all this stuff. This, we have to figure it out. We have to figure out the value of her investment at year 2 and year 6. So what we have to do is substitute 2 in for x, because x is the number of years, right? We have to substitute 2 in to figure out that value. So if I did f of 2, 8,001 plus 0.03 divided by 4 times 4 times 2, and I'm going to solve this. So it's not the best way to write all this. Okay, so I'm going to do 0.03 divided by 4, add it to 1. I have 1.0075, and 4 times 2 is 8, right? Okay, so I'm going to do 1.0075 to the power of 8. I'm going to type this all in once so I don't have to do bad rounding. Okay, to the power of 8, and then I'm going to multiply that by 8,000. Okay, I got approximately, and again, I'm going to round, we're talking about money, $8,492.79. So this, I'll slap a money symbol on it. That's how much money it was after year 2. That's f of 2. Now let's do f of 6. So let's figure out how much the investments were after 6 years. 8,001 plus 0.03 divided by 4. 4 times 6. So that would be 1.0075 again, right? But this would be 24. 4 times 6 is 24. So I'm going to do 1.0075 to the power of 24 and then multiply it by the 8,000. I got, let me do another approximately symbol. It's approximately 9,571 rounding and 31 cents. Okay. So what I have here, at year 2, it was worth $8,492 about. At year 6, it was worth $9,571. So her investment increased by, I don't know, a little more than $1,000, right? From $8,400 to $9,500 over 4 years. So let's calculate the average rate of change. So it changed. So if we do 9,571.31, subtract 8,492 and 79 cents. So how much? That's telling us how much her investment went up over from year 6 to year 2. So I'm just going to write 6 minus 2, which you could just put a 4 there, right? Now let me subtract those. 9,571.31 subtract 8,492.79. So it went up $1,078.52. So the average rate of change over those 4 years from years 2 to 6, finally answer here, divided by 4, I got on average it's going to go up by 269.63 per year. An increase of that per year. Okay, that's the average rate of change. All right, I'll let you do the rest.